Hello everyone and welcome you all to this video lecture on subject name hydraulics and pneumatics. The topic is pneumatics and its components. So what is meant by pneumatics? Pneumatics is the system used pressurized gas to transmit and control power. As the name implies, pneumatic system typically an air is using for the media in the system because air is a safe and low cost and it is easily available in the environment, and it is particularly safe where there is no electrical spark could ignite leak from the system components. So these are several reasons for considering the use of pneumatic system instead of hydraulic system. It will no inertia than the liquids or the some fluids. Therefore, in the hydraulic system, the weight of the oil is a potential problem when the accelerating and deaccelerating actuator and when suddenly opening and closing of the valves. So these are some drawbacks coming out from the system. Then we need to study the pneumatics. Myself, Professor M.R. Pardeshi, Mechanical Engineering Department, K.K. Wag Institute of Engineering, Education and Research, Nasik. So our today's learning objectives are: apply a perfect gases law, describe the purpose of compressor, explain the purpose of fluid conditioners, and last one is to describe the purpose of control valves used in the pneumatics. So we'll see one by one. First of all, the gases which are used in the pneumatic system. First is Boyles Law. Boyles Law states that if the temperature of the given amount of a gas is held constant, the volume of the gas will change inversely with the absolute pressure of the gas. So the constant temperature comparison, the constant temperature process is there. So P1 is less than P2. T1 is constant, that is T1 is equals to T2, and V1 is greater than V2. So we can write V1 upon V2 is equals to P2 upon P1. So this is called Boyle's law. Then next is Charles law. Charles law states that if the pressure on a given amount of gas is held constant, the volume of the gas will change in directly proportional to the absolute temperature. So in case of Charles law, the constant pressure heat addition taken place. So heat is going to add and volume, obviously V1 is less than V2, and due to the heat addition the volume is going to change, and the pressure P1 is same as P2 because it is a constant pressure process. And the what about the temperature is changing. So the this is called Charles law, that is V1 upon V2 equals to T1 upon T2. Then next law is the Gay-Lussac's law. In the Gay-Lussac's law, it states that if the volume of the given gas is held constant, the pressure exerted by the gas is directly proportional to its absolute temperature. So the constant volume heat addition process is taken place where the V1 is same with V2 and T1 is greater than T2. The constant volume heat addition process is there. Again, T1 is greater than T2. So the from the equation we can write P1 upon P2 equals to T1 upon T2. So by combining these three laws, the general gas law we found can be combined into a single general gas law defined by P1 V1 upon T1 is equals to P2 V2 upon T2. So the where by holding temperature, pressure and volume is constant, the general gas law reduces to Boyle's law, Charles law or Gay-Lussac's law respectively. For example, if T1 is equals to T2, the general gas law reduces to P1 V1 is equals to P2 V2, which is Boyles law. So general gas law is used for any kind of hydraulic as well as pneumatic components or in case of accumulators. Then next component is compressor. So compressor is a machine that compresses an air or another type of gas from a low inlet pressure to a higher desired pressure level. This is accomplished by reducing the volume of the gas. Air compressor are generally positive displacement unit and rate are either of the reciprocating piston type or the rotary screw or Rotaryvane type of compressor can be used. So during downward stroke, pressure inside the cylinder falls down up to the atmospheric pressure due to pressure difference, and the inlet wall is open. As the piston moves upward, the inlet wall gets closed and the pressure increases, makes the exhaust valve to open and delivers the air to the outlet. So you can see from this construction diagram, this is the inlet wall, this is the air outlet, this is the piston, this is the crankshaft connecting rod, and this is the staging of compressor. So the multi-stage compressor, if the compression of air from initial to final pressure is carried out in more than one cylinder, then the compressor is known as multi-stage compressor. So the staging is dividing the total pressure among two or more cylinder by allowing the outlet from the one cylinder into the inlet of the next cylinder and so on. So the multi-stage of compressor are used. It is reducing the input power requirement and increasing the efficiency of the compressor. Then screw compressor. Similar to screw compressor, the compression is accomplished by rolling the trapped air into the progressively smaller volume of the screw rotates. In between that, the meshing of the screw is there. Component number 2 and 1, these are the two screws. The component number 3 is the casing. This is the inlet of the air and the outlet of the air. So at the inlet, that screws are unmeshed, due to that the volume will be increasing, and at the outlet of the casing, that screw starts to mesh, so the volume will be decreases and pressure will be increases. So the precisely measured amount of filter and cooled air is injected into the compression chamber, mixing with the air. It is compressed in single stage, or the compressor are available with the capacity 450 and in pressure 120 psi. Then next one is the rotary vane compressor. In this, the cylindrical slotted rotors run inside the stationary outer casing. So this is the stationary outer casing, orange portion. This green portion is the rotor and the red portion is the vanes. That vanes are compressed and decompressed. Compresses at the outlet portion and decompress at the inlet portion. Due to that the volume is increasing and volume is decreasing at the outlet, and it sucks the air from the inlet side and it delivers the air to the outlet. So as the rotor runs, air is trapped and compressed between the vanes and then discharged to the port of the receiver. And sometimes the vane uses the compression spring continuously, it will compress and decompress. Due to that, the compressor can be operated up to approximately 50 psi and in the stages 150 psi in the two-stage design of the compressor. Then if you talk about the various components used in the pneumatic system, first and very important component is used in the pneumatic system, that is filter. The function of the air filter is to remove the contaminants or the impurities from the air before it reaches that the pneumatic component such as valves and actuators. So filter is act as a secondary air treatment component after the compression of particular air, that has to be filtered out first and then it goes to the enter into the various components. So it will filter out the particle range from 5 micron to 50 micron, and the air enter the filter swirl around due to the deflector cone. So this is the deflector cone is using here. Due to that, the air is inside the filter will get swirled. This is the baffle. This is the condensate moisture. Moisture is present in the air that is collected at the bottom side, and the centrifugal action causes the large contaminant, the water vapor, to be flung out, which gets collected at the bottom, and the baffle plate is provided to prevent the turbulent air from the splashing of air into the filter cartridge. At the bottom of the filter bowl there is a drain plug here is provided, which can be opened manually and to drain out the water and the solid particle from the filter. So this is very simple working of air filter. Then we move towards another component is a lubricator. Lubricator is the device to ensure the proper lubrication of internal moving parts by using the lubricator. Lubricator works on the venturimeter principle. If you remember, you have been studied that venturimeter in second year in fluid mechanics. So inlet is there, outlet is there. So intentionally convergent and divergent type of nozzle is creating, and in between that the throat section is created. Due to that, velocity is very high and pressure is very low. Due to that, the oil will be sucked from this tube with the help of siphon, and it will lift up and it will mix proportionately with the air to the outlet air. So the air is coming out from the inlet side, it will mix with the mixed oil droplets proportionately and it will given towards the next component. The oil drops inside the throat zone where the velocity of air is high. In this high velocity, air breaks the oil drop into the tiny particle, thus the mist of air and oil get generated. It is difficult to hold an oil mixture air in the air receiver as oil may settle down. Thus air is lubricated during secondary air treatment process. Low viscosity oil forms better mist than high viscosity oil, and hence ensure that oil is always present in the air. So this is the proper function of lubricator. Then if you talk about the third part of the pneumatic system, that is air pressure regulator. Now previously we have seen that filter, that is filtering out the air, then second part lubricate the air, and third part now it is a regulate the pressure of that air. So the function of the air pressure regulator is to regulate the pressure of the incoming compressed air. In that case, the spring is using, adjusting screw is using, body, main spring, diaphragm, valve, and damping screw, damping spring, and vent hole is using. So it consists of diaphragm, valve, main, damping spring, and the diaphragm allow the proper amount of movement for opening and closing at the wall seat. Means here the wall seat is there. Proper opening and closing can be done by means of the diaphragm, that is the flexible member number 4. When the adjustable screw is in fully retracted position, the wall is closed. When the adjusting screw is turned to compress the adjusting and damping spring, the wall is opened and allow air from inlet to outlet port. The pressure of the outlet air depending upon the size of the wall opening that is maintained, and which can be determined by the compression of the adjustable spring, which is can be varying by means of the adjustable screw. So the damping spring is provided to act as a damping device needed to stabilize the pressure depending on the system. So here is the inlet and here is the outlet. So the system required how much pressure that can be set by the adjusting screw as per as the application by using the air pressure regulator. Then next, if we combine these all three components, it will find the FRL unit. What is meant by FRL unit? F means filter, R means regulator, L means lubricator. So filter out, regulate it and lubricate it. If we combine these all components, we'll get this particular component. So here is the filtering with drain, regulating with the help of this variable by using adjustable screw and spring arrangement, then with the help of pressure gauge we can measure it whether the system requires that much pressure or not. Then ultimately, lastly, we can lubricate that particular air, regulating that air to the system. So the simplified ISO symbol for the FRL unit is this. So this filter, this is regulator, and this is lubricator. So this is the inlet of the air, this is the outlet of the air. So this is the unit, it is called the FRL unit. This is very important component of the pneumatic system. It is called as the secondary air treatment. After the compression of air, it will act as a secondary air treatment of the compressed air. Then if you see this detailed component, this is called the filter, this is called regulator, this is called lubricator. And you can see this physical diagram of this filter, lubricator and regulator. You can see, you might have been seen in the lab, and this is the compressor. So after compression it will act as a secondary air treatment. In moving towards next component, it is muffler or pneumatic silencers. So the function of the muffler is to reduce the noise caused by the rapidly exhausting air or stream flowing into the atmosphere. Noise in the air system may cause nervous tension, mental fatigue, lack of concentration, and dissatisfaction among the operator. So the components used in the muffler is the flow diffuser, plenum section, absorption splitter, and the support bracket. Here is the porous metal is using. Due to that, the exhaust air stream enter one end of and passes out at another end, passing through the series of baffles. These baffles are perforated with the large number of small holes, and outer shell act as a barrier and helps to guide the stream towards the exit to the atmosphere. So as I told you, the porous metal is using, due to that the restriction is created and noise will be reduced. So this is again important component used in the pneumatic system, that is called muffler or pneumatic silencer. Then if you talk about the control walls, the pressure regulator, this is the puppet type of regulator wall. Pressure regulator is there. So the purpose of pressure regulator is to set the working pressure of a particular circuit, or it is depending on the application. So sometimes it is installed within a circuit to provide two or more different pressure level for the separation portion of the unit, and the adjustable screw is using to adjust the desired pressure or at the set pressure that system wants. Then next component is the check wall. The purpose of the check wall is to allow free flow of compressed air in one direction only and to prevent the flow in opposite direction. Here this is the no flow because the component is this is closed, and this is the free flow is there. From the ISO symbol, when the flow is forward direction, the compressed air is pushes the disc seal and allows the free flow, and if the flow is attempted in the opposite direction, the seal is in closed condition, thus the no flow is permitted. You can understand from this symbolic representation, this will be the free flow, means this puppet will unseat and the free flow will occur, and from this side if the flow is there, so the puppet will seat and the no flow condition taken place. So this is the simple of check wall. Then another wall, it is again another type of direction control wall. It is a shuttle wall, or you can say that it is a double check wall. In the shuttle wall consists of two inlet ports and one outlet port is there. So you can see here the two inlets are there from this side and from this side, and one outlet is there from this side. Here also you can see here this is one inlet, this is another inlet, and this is the outlet of this particular wall. If the pressure in the right inlet port is greater than the left inlet port, the spool closes the left portion and the right portion air will passes and output will generate. When the pressure at the left inlet port becomes greater than the right inlet portion, the spool moves and closes the right port of the wall, and it allows the flow through the left port and the output will be generated. So the shuttle wall, it can be treated as a OR gate. or the you might have been studied that OR gate in mechatronics. So see, principle is same. The two inlet is there and one outlet is there, either or. Then next component is the direction control valve. There are various types of control valves. The purpose of the DCV is to direct the air and the flow of pneumatic fluids. So DCV are used to start and stop and regulate the direction of the air flows. So here is the some rotary type of valve is there. Here in case of this valve, P is open to B and all the wall is closed. So it has a stationary casing, and inside this stationary casing the rotor is using. At one time pressure P port is open to the A port and B is open to the R port, and at the other point this B is see the P is open to this B port and A is open to this R port. So based on the number of ports present in that sliding spool type, in this diagram, this one is open to 2. If this spool is moving, now 2 is open to 3. Another type is poppet type. This pressure is reaches towards the spring pressure, it will unseat and this P is open to A due to this poppet wall. So there are various types of walls depending on the construction. Then two-way walls, basically on-off type of wall, it is called, similar to water tap, which is allow flow or stops flow manually. A normally open or two-way wall allows flow in its normal position and restrict when it is actuated. A normally closed wall restrict flow in its normal position and allows flow when it is actuated. It is called two-way wall. Then three-way wall, in construction you will find this is the air supply, this is the towards cylinder, and this is the exhaust. So the air supply, firstly it is open to the cylinder from the symbolic representation. This is the P is open to A and this is blocked, and in another position now P is blocked, now A is open to R, that is reservoir or the exhaust. So one port is connected to any one of the two port. This valve may be used to pressurize one port and exhaust to the other port. This valve can be used as a pilot relay to operate the other valves, and basically three-way valves is used when the single acting actuator is there. Then another type of valve is four-way wall. Four-way wall is the inlet port is connected to the cylinder port A and cylinder port B is connected to the exhaust port, and in the another position when the wall is actuated it will become unseated and inlet port is connected to the cylinder port B now in the rod end side position, and cylinder port A is connected to the exhaust port. So it is very simple, and then 4x2 position is there, two position is using, and it is used when the double acting cylinder or double acting actuator is using. Then quick exhaust valve. The purpose of the quick exhaust valve is to exhaust the cylinder to the atmosphere more quickly. Basically that valve is using when the cycle time has to be reduced. If the task is completed and we need to reduce the cycle time for the idle time, that can be reduced by using this quick exhaust valve. The spring return single acting pneumatic cylinder is increase the speed by using this quick exhaust valve. The principle behind this valve is the reducing the restriction resistance to flow of air. The air can be exhausted to atmosphere more quickly. You can see here the actuator, in between the actuator and DCV, the quick exhaust valve is using. If I using this quick exhaust valve, so cylinder will retract quickly. So your task is completed at the time of extension stroke, but the retraction stroke is idle. So that idle stroke has to be minimum, then ultimately the cycle time will be reduced. So keep in mind that. So by using this quick exhaust valve, we can minimize the cycle time. When the DCV switched is to next position, air from the cylinder port A pushes movable disc to mask the inlet port P, where the air is exhausted through the exhaust port R immediately from this side. Next is flow control valve. The purpose of flow control valve is to regulate the volumetric flow of the compressed air to different parts of the pneumatic system. The spring loaded disc allow free flow in one direction and the adjustable or control flow, or we can say the metered flow, in the opposite direction. So the here is the metered flow is there. Some restriction is there due to the adjustable spring and the screw is there. Here is no meter flow is there, so the free flow is there. So if I controlling the speed of the actuator, we need to metered flow is there, and we can set the speed of the actuator as per as the application. The tapered brass stem control the flow adjustable by controlling the flow through the cross hole disc in the disc. Here the metered flow is there, here is the free flow is there. So this is the end of this particular session. Thank you for watching. Thank you very much.